So this pilot study will allow us to test the efficiency of the wetlands to treat Buckman and Southwest water and give us a resource that isn't the river, right? So the goal of Senate Bill 64 is get the water out of the river. This gives us a place to finish that treatment and elevate the quality of this water for other uses. So locally, it answers our question for future water resources need through that replenishment project. We're able to take water from these wastewater plants and treat it and recharge the aquifer with it, which provides a benefit to not just JEA as an entity, but our customers and the broader region.
So with this pilot study, we have the opportunity to not only take a normal constructed wetland, which we have tons of data on and have been implemented across the state of Florida, but use that as a control versus the other cell, which uses ozone as a pretreatment. And the working theory is that the ozone would break down a lot of these contaminants of concern and allow the wetland biology, the plants, and all the biology that goes on in the wetland to better assimilate those contaminants. And then by having two cells, running them in parallel side by side and collecting data on the front end and the back end, then you can do that analysis to demonstrate which of the two configurations work best.
So right behind us, we have two half-acre wetland cells. One of them will receive ozone pretreatment, and the other will be our control cell. And we're doing ozone pretreatment to see if that enhances the treatment wetland performance, and if the ozone will kind of break down the pollutants to make them more bioavailable for the treatment wetland.
Inside this whole facility, we're able to generate the ozone using ambient oxygen, added electricity, and we're generating the ozone here. We're using a side stream injection system here, which is just a really good way for high efficiency of applying the ozone and getting it to dissolve inside of the water. And this contactor right behind us, as you can see, there's a lot of sample pores throughout. It's really a serpentine path that the water has to go through. It's a 5-minute contact time inside that plastic container. So we're able to collect water throughout that path at different time signatures to understand how much of the ozone has reacted with the organics inside the water to really optimize that applied dose. We'll test various doses throughout the project to understand what the right dose is and try to connect it to a wetland response.
Each cell has both deep zones and emergent marsh zones. And so the emergent marsh zone is about 1 foot in depth, and then the deep zones are about 3 feet in depth, and they have like floating aquatic plants. And so we use those to distribute the water across the wetland cell so that it flows like a sheet and then enhances treatment performance. Then the downstream deep zone collects that water and is tied to our outlet agri-drain control structures. And these are water level control structures that have removable stop blocks, and they'll also control the flow mode of each cell, which is another variable that we're looking at. So we want to determine if the surface flow wetland mode, where water flows across the wetland and exits at the surface, if that performs better than an infiltration wetland, where all of the water exits through infiltration and then through 4 feet of sand media that we have below the wetlands into a collection system to kind of simulate a groundwater recharge wetland or an infiltration wetlands. Once the wetland plants grow in after 6 months of vegetation establishment, we'll begin our pilot study in November of 2025. And we'll conduct that for 2 years. And we'll be testing all sorts of parameters in the water, drinking water standards, nutrients, pharmaceuticals, PFAS, industrial parameters like hexavalent chromium. We'll also be looking at the soils to see if there's any absorption of those parameters to the soils within the wetland cells. And then we'll also look at the plants to see if there's any plant absorption of some of these compounds.
I think the most innovative thing obviously is the ozone component of this. By introducing ozone as a pretreatment and then seeing how that may impact the contaminant removal and the removal efficiency and the treatment ability, and being able to compare that side by side is truly innovative and groundbreaking. We really have the opportunity to potentially invent a new treatment approach for reclaimed water and looking to do aquifer replenishment on a regional basis.
So on the surface, the wetlands park that ultimately will be created will provide tourism opportunities for local schools, local groups to come and tour and look at just the wetlands in general. But it'll also educate on the overall water cycle, you know, where our water comes from, how we treat it, how we collect it, this large water recycling process that's been going on for a millennia. We're just accelerating it and reusing it over and over again at a quicker pace, right? And then more broadly applied is this now becomes a resource that the broader region can use to recharge the aquifer throughout the state, whether that be Santa Fe, Swanee Rivers, or even Keystone Heights. So the aquifer itself goes from South Florida all the way up into almost South Carolina and Alabama. So we're trying to do our part to restore and recover. You know, being responsible stewards, not just to protect our customers' interests, but our environment's interest, right? So that's what we strive to do day in and day out, is protecting our customers and protecting the environment that we live in, right? That's our job and our obligation is to make sure they get the resources they need, it's safe and reliable, and as well as we protect the environment that we all live in. That's our goal, that's what we try to do every day.